Hi students, this is VLSI Design. Today's topic is Introduction to MOS Transistor, presented by R. Subhashini Devi. After this topic completion, students will be able to understand, explain the electrical properties of MOS transistor, explain the DC and transfer characteristics of a CMOS inverter. Then different integration levels are present in the VLSI design. First one is SSI. SSI means small scale integration. Small scale integration means if eligible with less than 12 gates per chip. Then MSI. MSI means medium scale integration. It will have less than 100 gates per chip. Next one LSI. LSI means large scale integration. It will have up to 1K gates per chip. Next one VLSI. VLSI means very large scale integration. It will have up to 10 gates per chip. Next one ultra large scale integration. It will have up to 100K gates per chip. Last one gigantic scale integration. It will have the limit of up to 1 MHz per chip. These are all some integration levels in VLSI design. Then next we are going to see about the structure of MOS transistor. MOS means metal oxide semiconductor. It will have many layers. That's why we are having the metal oxide semiconductor name. Metal oxide semiconductor means it will have the some metal layers form the transistor. That's why first one is gate and next layer is formed by the oxide, and then oxide is having the silicon dioxide material. Next substrate. Substrate means it will have the silicon layer. It is P substrate is here. It's depend upon the type P or N types. Two terminals here. Mainly we are having the four terminals in the MOS transistor. First one is source, second one is gate, third one is drain, and then fourth one is P substrate. Substrate is depend upon the P or N type. Always the substrate is made up of silicon materials. Many of the materials are to form the metal oxide semiconductor. That's why it is called the metal oxide semiconductor. Next, we are having the structure and operation of the metal oxide semiconductor. Here we are having NMOS type and PMOS type. NMOS means negative metal oxide semiconductor. PMOS means it is the positive metal oxide semiconductor. Here we are having the three terminals, drain, gate and then source. The different structure of the FET is given here. Then PMOS is also having the many structures and symbols. Here only difference between the NMOS and PMOS is that arrow symbol. That arrow towards the gate means it is the NMOS, it's a PMOS. Next, structure of the MOSFET. It will have, it is the N channel. It will have N plus, that means source and drain is having the majority N plus. Then here N plus means it is a substrate is almost P type only. That means body is a P type substrate. Then in between the source and drain we are having the channel length. It is a oxide thickness, that is silicon dioxide material. Then here one metal is having the gate layer. Then it is the body. These are all four terminals in the metal oxide semiconductor: source, gate, drain, and then substrate. The channel length is depend upon the region of operation. We are having three regions that are cutoff, saturation, and linear regions. Here, enhancement type MOSFET, we are having the channel also. If the limit is gate to source voltage is less than threshold voltage, means here we are having channel is also produced, that is deflection regions. That means enhancement mode of the metal oxide semiconductor, that means MOSFET. Next one, linear region. Mode of regions, we are having three mode of regions are having. First one, linear, saturation, and cutoff. It's depend upon the limitations of voltages. It will differentiate each and every region. First one, linear region. In this linear region, we are having gate voltage is greater than threshold voltage, means it will have called the linear region. Here we are having the channel also. The channel is also produced in between the source and the drain. Next, saturation region, almost the the channel is produced. Then the channel is start to disappear from the channel. Next, this limit is gate voltage is less than greater than the threshold voltage, and then drain to source voltage is also greater than the drain to saturation voltage level. Then it is called the saturation region. Next one, channel approximation. This channel approximation, we are having totally that reflection region, then channel length, almost all are the having the region that is shown in the figure. That channel, that means characteristics of the MOSFET. We are having the VA characteristics, that means voltage and current levels are defined here. That means the voltage increases gradually, that current is also increasing. This is all the regions. Three regions are shown in here. This is the linear region, and this one is saturation region, and this one is cutoff region. After this topic, we are having some quiz questions, that are what are the necessary conditions for the different region of operation in CMOS inverter. It can be able to understand from the students. Thank you.